the very highest vision here, right, is that it should be a long-term network society supporting wireless technology. But I think what's most interesting is if you start reading some of these little, maybe hard to read fonts here. But these are things that don't really exist today. You don't have multi-hop communication. Just because you have just because you are accessing Netflix, I can't access Netflix through you. I have to have my own connection to the network. So this is something that has been talked a lot about, and that will now, should be supported within the, the 5G technology. So these two devices could talk, like the truck driving by here could use this gentleman's connection to send something if it didn't have all the abilities itself to communicate to the network. So some other types of devices could access other devices and then send it on up to the network, for example. Then you have the electricity metrics, these types of infrastructure that is around us in society everywhere. Not just fire alarms, but perhaps also all the electric cables that is going around the world. You have tunnels, you have all kinds of infrastructure that you could, want to be communicative. You might want to know a little bit more about the status of all this infrastructure that is out there today than you do know today. So this is something that it says ultra reliable communication here. So machines, for example, tunnels, as I talked about, bridges. I mean, something that's always out there that you might want some sensors to be, communicative back to networks. We have machine-to-machine already today. LTE supports machine-to-machine type of applications. This is now being enhanced in order to be much, much more machine-to-machine types of application. I mean, if every beamer like this and every anything that has electricity pretty much should be able to talk to the network, then we needed to take a little bit of a larger vision on how many connected devices that is. We already have the 50 billion connected devices, and now we needed to take a little bit extra step here to make that happen, and then it would be part of 5G. And then here is the vehicle-to-road communication, back to anything that has some type of a benefit of being connected could be connected. Your car could be connected to the car in front of you and to the car back of you. And maybe to the car 2 kilometers up ahead. And you might not be aware, but the car might need to be aware, right? Is there a stopping point? What is the average speed of the car traveling the same directions as I am on the same road, up ahead? Is it slower or higher? I mean, there are all kinds of things you can think about here, right? And then the last thing is something that is called ultra-dense deployments. And here, if you start talking about very, very high frequency bands, then you have to have a very dense network. Because these high frequency bands, they have a lot of dampening. They don't reach very far. It would be, if I would stand here, you wouldn't hear me in the back, right? So they're very, very hard frequencies to have very large ranges with. But if you deploy them extremely dense, you can have a lot of capacity coming out of them. So if you go up today, the 2.6 band is here, right? This is the highest band that we have today, that we have commercial traffic for, and it happens to then be an LTE band. So then if you see, this is a factor of 10 as we move out here. And there's a lot of spectrum out there that can be used, but today we don't really know how to build that type of equipment very cost effectively and how to deploy these very ultra-dense deployments. But it's a vision for 5G.
Just to put things in perspective, I don't know if you could explain a little bit, because of course, as you said, there's a lot of talk about 5G now, which is based on peak speeds and so on.
Yeah.
But if you can put in perspective how we are in Ericsson working with the group of standardization and usually how long it takes to, just briefly.
Yeah.
Because this is of course a work that comes from
this is a consortium, right? Yeah. This is a consortium. So 3GPP. That's that's when you come down to actual standardization and actual laws, you can say, in the mobile technology, right? We're not really there yet. We don't have all the standards written for 5G. And if you look at the time frames here, now this is 2015, so we're in the middle of here. We're in the middle of having, 4G, we have 3G, and we have Wi-Fi accesses, for example. And as we move up here, maybe in 2020, somewhere in that time frame, perhaps we have all the details of how the 5G technology should look like. So it's some ways ahead. But 5G also includes evolving the existing networks that we have today. It's not just something that comes here with new frequency bands and a completely new technology. It actually involves the others. You see, they're actually still in here in this 5G box, you can say. So the idea here is that the new wireless technology should also use some of the legacy technologies, and then of course you have to evolve them. Otherwise they wouldn't be able to work together. So this is the vision for the future, with ultra-dense, your cars talking to each other, the bridges talking about how much weight they carry and what kind of cars are traveling over them, and tunnels and electricity. Everything that could be connected and that can benefit from the connection will be connected.